Okay, welcome to this video where we're going to be having a look at a practice paper 1 for the GCSE exam. Now you've either come to this video because you have scanned the QR code on the front of the booklet, or you found this video just on its own. If you haven't already got the booklet, I'm just going to show you how you can go about downloading that so that you can follow along with me. Now in the description for the video, and it's not this video on the screen, but this is a previous video that I did similar to this one, if you click into the description, which you can see on the right hand side, I list in there the links to download both the checklists and the booklet. So I'll show you both in just a moment, but you can find them at the top of the video. If you keep scrolling down, you'll see that I link for both tiers the series of the 3 papers. So whether you're doing the foundation papers, you'll have all 3 there, or whether you're doing the higher paper, you'll have all 3 there. Below that, I always list some useful videos for revision, along with my everything you need videos for both of those tiers. And if you keep scrolling all the way down, you'll see there that I've got the timestamps for every question in the video with the full lesson next to that, so you can click in at any point and watch a full lesson on that particular topic. Really good if you are finding one of the questions a little bit tricky. You can go in and you can practice some more similar style questions and obviously access a full lesson on that. So everything's there. It's really easy to use. You can use the chapters feature as they're all timestamped. You can click into the chapters on the start of the video just by clicking on the screen and clicking that word there where it says where we're at, and you can flick through the booklet having a look at different topics along the way. Always good if you don't want to watch it all in one go as well, because you can just jump back and access the question that you got to. So loads of stuff that you can do there. So before we get started on the video, I'm just going to show you the checklist. So here is my checklist that you can download from the description like I showed you, but I just wanted to show you some of the rationale behind the choices of the topics in this video. So obviously there's a lot of topics that can appear across the 3 papers. So what I've done is I've gone through the checklist and I've picked off a huge variety of those topics, as you can see. Loads of the topics from number, algebra, some of the trigonometry topics, and then also we've got some topics from geometry, probability, ratio and proportion, and obviously from statistics there we've got a histogram on this one like you can see. So obviously there are any of these topics that can appear on your paper 1, but what's important is we get a good variety of all these topics here across the 3 papers. So for example, histograms on this paper, well, that might appear on paper 2 and 3. None of us know until that paper is actually released. But what I'm going to do over the course of the 3 videos looking at these papers, I will make sure that we get a good coverage of the vast majority of these topics. So do make sure that you stay subscribed to the channel and you check the description as well to find the other videos in this series preparing for your GCSE. So there we go, without further ado, let's get started. Okay, so starting with this video. Obviously this is for the higher tier, and obviously you've got the booklet here and you can scan that QR code at any point and it'll bring you back to the video. Obviously you can access this booklet in the description. So obviously when it comes to these papers, there is no guarantee that any of these specific topics will be on your paper, but across the 3 papers we are going to get a broad variety of lots of different questions that will appear on your exams. Okay, those topics are the topics that you're being assessed on, and if we cover the large majority of them, then there is going to be tons of them that obviously you'll have practiced prior to your exam. Obviously don't rely on this solely as your revision, it is just an additional bit of practice and an additional paper with some really good variety of questions. So starting with question 1, we've got work out the lowest common multiple of 24 and 56. Now when we're working out the lowest common multiple, remember we are looking at multiples here, so they're times tables and not their factors. So if we draw a table, we go for 24 and 56. We want to make sure we do at least 4 multiples of both of them just to secure that first mark. 24 or 24 gives us 48. Then we're going to get adding the 4 and then the 20, so 52, 72. Then we've got 96, 120, 144, and then I'll probably move on to the next row here. So let's go with another 56, that'd be 112, and then we'd get 168. Adding the 6 is 174, add the 50, 224. So we've not got a match just yet, so let's go back to the 24s. Adding 24 to 144 does actually give us our 168, which has appeared in our 56 multiples. So 168 would be our lowest common multiple, and that would be our final answer for question 1. On to question 2. Okay, so we have in a bag there are only red counters, blue counters, green counters and yellow counters. A counter is taken at random from the bag and the number of blue counters to the number of green counters is 3 to 4. Now whenever we're looking at probability from a table, we know that these all have to add up to 1. So the first thing to do is to add together what we've got already. So we've got 0.4 add 0.25, and that in total is 0.65. Well, if we then take that away from 1, you can take your time working that out. That one hopefully isn't too bad to just look at. That's 0.35. So that's what's left to share between blue and green. And it says that that's in the ratio 3 to 4. 3 to 4 is a total of 7 parts, so we want to divide that by 7. 0.35 divided by 7 is easy enough to work out because it's 35 divided by 7, but as a decimal that gives us 0.05. That's 35 divided by 7 is 5. So each of those parts is worth 0.05. We have the ratio 3 to 4, so we want to multiply both of those by 0.05. 3 of those would be 0.15 and 4 of those would be 0.20, or you could write that as 0.2. So putting those into the correct place, blue would be 0.15 and green would be 0.20. Or I'll just write 0.2 for my final answer there. Obviously you could have different language for that as well. It could say something different, obviously not the ratio 3 to 4, but it could say one is twice the size of the other. For example, if it said blue was twice the size of green, then that would be the ratio 2 to 1. And you'd have to then obviously approach that slightly differently, but it could be given to you in words. But there we go, there's question 2. Finding the nth term of an arithmetic sequence. So the first thing to do is to find the difference between these terms. From negative 3 to 1 is 4, and from 1 to 5 is 4. As long as I have 2 matches there, I know that it is an arithmetic sequence, but this question does actually tell you that it's an arithmetic sequence, so we don't really need to test more than 1. But if it goes up in 4s, our code, our nth term, will be 4n. Then we can write the 4 times table. There are obviously tricks to this, but if you look at that, the sequence we've been given is 7 less than the 4 times table. From 8 to 1 is taking away 7, from 12 to 5 is taking away 7. So it is the 4 times table, take away 7. So our nth term, final answer, 4n minus 7. And there we go, there's working out the nth term. On to question 4. One sheet of A3 card has an area of 1/8 metre squared. The card has a mass of 160 grams per metre squared. So that was only 1/8 there for one piece of card. Work out the total mass of 25 sheets. Now there's different ways that you can approach this, but I think the easiest way to approach this is if we find the mass of one piece of card. So one piece of card has that area of 1/8 metre squared, and it's 160 grams per metre squared. So if we find 1/8 of 160 grams, that will tell us the weight of one piece of card. You can find that by dividing 160 by 8. That's not the worst calculation to do. I'm going to use bus stop. 8 goes into 16 twice, and it goes into 0 obviously 0 times. So one piece of card has a weight of 20 grams. And I'll put grams with that so I don't forget to put my units. This says work out the total mass of 25 sheets. So the calculation I want to do is 25 multiplied by 20. And that's relatively easy to do. You can do 2 times 25, which is 50, and then add the additional 0 on, so that would be 500 grams. Obviously take your time to work that out. You could do column multiplication if you wanted to, but that one's okay. So 500, not forgetting my units, grams. And there we go, on to our next question. So expand and simplify 2 sets of brackets. So the first bracket here wants us to multiply those by 3. So 3 times y would give us 3y. 3 times negative 2 gives us negative 6. On to the next bracket, we have positive 5 times 2y. Well, that'll be positive 10y, and then we have positive 5 multiplied by positive 1, and that is positive 5. Now we just need to collect like terms, so we have the 3y, add the 10y, and that in total gives us 13y. And we have the negative 6, add 5. Negative 6 add 5 is negative 1, so it all simplifies to 13y, take away 1. Simplifying with some laws of indices, we always just multiply numbers normally, so 5 times 7 would give us 35, and then when we have the same letters we can add the powers. So we have a u squared and a u to the power of 1, not forgetting to put that 1 in there so we don't forget to add them, because that will become u to the power of 3. We then have w to the power of 4 multiplied by that w to the power of 3. Adding those is w to the power of 7. Quick check to make sure that you've not missed any powers there. I'm happy with that, so 35 u to the power of 3, w to the power of 7. On to some standard form, writing 1.63 times 10 to the minus 3 as an ordinary number. 1, 6 and 3, it's a negative power, so the decimal which is between the 1 and the 6 is going to go left. So we're going to go 1, 2, 3 to the left, that's where the decimal is going to go. Under the loops, fill it in with noughts and tidy it up at the start. Then write that on the dotted line, so 0.00163. Writing 438,000 in standard form, well, we just need to see where's that decimal going to go. It's currently right at the end of the number. We want it to go here between the 4 and the 3. So that's 1, 2, 3, 4, 5 jumps. So that would be 4.38 times 10 to the power of 5, as we did 5 jumps there. So there we go, there's some conversions, and we've got a calculation. So working this out and give your answer in standard form. Well, again, the numbers just multiply the numbers. So 4 times 6, which are our starting whole numbers in these parts of standard form, 4 times 6 is 24. Again, when we are multiplying and we have the same base number, here obviously with standard form we have the base number of 10, we can add the powers. So we have 3 there and then negative 5. 3 add negative 5 is equal to negative 2. Obviously a plus and a minus next to each other like that is a takeaway. So we have 24 times 10 to the power of negative 2. We want this to be in standard form though, so we need to make this number at the start smaller, so 2.4, and then to balance it out we make the power 1 bigger, so negative 2 goes up to negative 1. And that'd be my final answer, writing that in standard form. So 2.4 times 10 to the power of negative 1. Okay, our next question. There are 240 bottles of drink on a shelf. Each bottle contains apple or lemonade or orange. And then we've got the ratio here, so apple to lemonade to orange. Half of the bottles are lemonade, 1/12 of the bottles of orange are removed from the shelf. So we need to find out how many bottles are actually on the shelf. So we're starting off with 240. There are 10 parts in this ratio. So if we do 240 divided by 10, we know that each part is worth 24 bottles. We then just need to multiply the ratio by 24 to find out how many bottles there are. So 5 to 3 to 2, multiply them all by 24. 5 times 24 is half of 5 times 10. Sorry, it's half of 24 times 10, so 240 halved is 120. 3 times 24, well let's do 2 times 24 first because that's 48, and we can just add another 24 onto that. So that would be, add the 4, 52, add the 20, 72. So that's how many bottles are on the shelf. But it says that half of the bottles of lemonade are going to be removed. So if we remove half of the bottles of lemonade, 72 would turn into 36. Again, might want to do the working out to the side. Half of 72 equals 36. And then it also says 1/12 of the bottles of orange are going to be removed. So 1/12 of, and the orange is the 48 bottles there, so 1/12 of 48. 48 divided by 12 is 4. So if we remove 4 of those bottles, that would be 44. And again, I'll put here, we're minus 4 there, we're minus 36 here, and all the other bottles there are staying on the shelf. So it says work out the number of bottles of apple as a percentage of the total number of bottles remaining on the shelf. Well, the apple is the 120. So we have 120, and I'll write this as a fraction first, out of whatever the total is. So if we add those up, 120, 36, and 44, they add up to 200. So that's 120 out of 200 as a fraction. That's going to help us out because if we simplify that, dividing the top and bottom by 2, that gives us 60 over 100. And 60 over 100 is 60%. So there we go. That was our ratio there once we had removed the bottles, and then we've written it as a fraction and shown all our working along the way. But we got to a final percentage of 60%. Okay, on to some perimeter. So it says here is a rectangle, and the rectangle is 4 by 10. It says the 12-sided shape below is made using 4 of these rectangles. Work out the perimeter of the shape. Well, some of the 4s we can see we've got 4 here, 4 here, here and here. We can also see some of the 10s, the full lengths. So we've got 10, 10, 10 and 10. And we've got part of a length here, and if we look at this line just here, we know this part is 4, the full length is 10, so this bit must be 6. And that's going to be replicated around the shape. So that's a 6, that's a 6, and that's a 6 as well. Now if we look at what we've got in terms of the perimeter, the distance all the way around, we have 1, 2, 3, 4 4s. So 4 times 4, which is 16. We have 1, 2, 3, 4 10s. So 4 times 10, and that's 40. And we also have 1, 2, 3, 4 6s, and 4 times 6 is 24. So if we add those all together, we get, let's have a look, 4, 5, 6, 7, 8, 80. There we go. So our perimeter of the shape is 80 centimetres. That wasn't the nastiest of questions, but they could have given it you in a slightly different way, which I think would have been more interesting. So you could have had something like this, where it told you that length there, and that'd be a length of 20 centimetres, because you'd have the 10, the 4 and the 6, and then maybe they could give you another length, like this one here. Maybe they could have said that, because that'd be the 4 and the 6, or that'd just be a length of 10, something along those lines, that just made it a little bit more interesting, so that you had to find the actual 4 and 10 yourself. But there we go, just a little bit of a perimeter problem just thrown in there. Not too nasty, so we won't complain. And so this one, write down the exact value of cos 60. Two of the key ones you have to remember. Cos 60 and sine 30 both have a value of 0.5. You could write that as a half as well, but you don't need to write both of them. So 0.5 or a half, either one of those is fine. Given that sine 30 is 0.5, work out the value of x. So whenever we're doing these, because you don't have to be given the 0.5, although 0.5 is a nice one, and we'll see why. So in this question, we're dealing with the opposite and the hypotenuse. And we know that that is therefore going to be using sine. When we're looking for the opposite, it's sine multiplied by the hypotenuse. So sine 30, it's told us is 0.5, so it's 0.5 multiplied by 12. And hopefully you know that 0.5 times 12 just halves the answer. So the answer to that is 6 centimetres. X is already given to us with centimetres, so we don't need to write 6 centimetres. We're not going to lose marks if we write 6 centimetres, but 6 is our final answer. Obviously, if you are given a different decimal, because you don't have to be given 0.5, you'd obviously just do a multiplication method. So here, if I didn't know that it halved the number, I'd do 12 times 5, which is obviously 60, and then hop the decimal back in, 6.0. So there we go, that's how we'd approach some of these slightly nicer exact values of trigonometry. Okay, so some transformations. Enlarge shape A by scale factor 1/3, centre 0, 1. So let's have a look at the vector to get to our first vertice on the shape. So to get there, I'd go 1, 2, 3 across, 1, 2, 3 up. So that would be the vector 3 across, 3 up. And we're going to multiply that by 1/3. So multiplying it by 1/3 is the same as just dividing it by 3. So if I do that, and if I put here times 1/3 next to both of those, that would become 1 and 1. So our new vector, to get our new point from that point, I'd only have to go across 1 and up 1. That's where the shape's going to start from in terms of that vertice. As well as that, the shape is going to get a third of the size. So where this height here has a height of 6, a third of that would only give me a height of 2. So that's going to go up to there. Across the top, that has a width of 3, so mine will have a width of 1. The same going down here, that has a length of 3, so that'll be a length of 1. We've now done all of the side lengths other than the final one, which I just need to then join up. So I always leave any diagonal ones to the end so that I don't have to try and do the scale factor there with a diagonal side. Although it wouldn't have been too bad, it goes through 3 diagonal squares, so it would just go through 1 diagonal square. So there we go, that's where it would end up. It doesn't say to label the shape or anything, so there we go. It ends up in that position. You don't have to shade it or colour it in or anything like that, but there we go, that's where our final shape is. Okay, so some estimations. So work out an estimate for the square root of 4.98 plus 2.16 times 7.35. Well, first of all, when we're estimating, we want everything to one significant figure. So let's just do this calculation inside. So we've got 5 plus 2 times 7. Obviously following our order of operations, that is 5 plus 14. 5 plus 14 is equal to 19. So it wants me to estimate the square root of 19. Now I don't have to round that 19, I need to think about what square numbers this is between. So if I write some of the square numbers, we've got 1, 4, 9, 16, 25, and I don't need to go any further because the square root of 19 is somewhere between those two. So obviously the square root of 16 and the square root of 25, we've got 4 and we've got 5. So it's somewhere between those. You can try and be as accurate as you want here. Is it closer to 16 or 25? Well, it's 3 away from 16 and it's 6 away from 25. So technically it should be closer to the 4 than it is the 5, but we are just estimating, so maybe I'd just go with something along the lines of 4.4. You'd be allowed anything probably here from 4.1, 2, 3, 4. You'd probably even be allowed 4.5. But the important part there is that it's between 4 and 5, and it is either halfway or less than that 4.5. So there we go, 4.4 would be a good estimate for that one. Okay, so a cafe owner sells 10 different types of sandwich. Mikael buys a different type of sandwich on Monday, on Tuesday and on Wednesday. In how many ways can he do this? So on Monday, he has 10 different options of sandwiches. On Tuesday though, he's going to buy a different sandwich, so he's only now got 9 options. And on Wednesday, he's going to buy a different sandwich again, so now he only has 8 options. So when it comes to the product rule, when you're looking at combinations like this, you just take the amount of options on each choice, or on each time, each day in this case, and multiply them together. So we just need to work that out, and that'll be our answer. So nice and easy, 10 times 9, and in fact, as multiplying by 10 is so easy, it might even be easier to do 9 times 8 to start with. It doesn't matter which way we do them, as we are multiplying all of them, 9 times 8 is 72, and 10 times 72 is 720. Probably an easier way. Doesn't really matter if we did 10 times 9, that's 90, times it by 8, again we still get that 720. So 720, final answer, and there we go, that's using the product rule for counting. The important part there is where it says he buys a different type of sandwich on Monday, Tuesday and Wednesday. And the fact that he bought a different type of sandwich meant that we had to reduce the amount of options each day. So there we go, 720, final answer. Okay, so drawing a quadratic graph, and we're doing this on a non-calculator paper. It's much easier when we have a calculator paper to do this, but that's not going to stop us. So complete the table of values for y equals x squared minus 2x plus 2. That's okay, that's quite a nasty one. So in terms of doing this without a calculator, we just need to substitute these values into that equation. I tend to start with the number up here, rather than start with the negative numbers. I just like to get a few right and start to get confident with subbing into the formula, rather than starting off with -1. So if I do that, we've got 4 squared, take away 2 times 4, which is 8, add 2. So that's 16, take away 8, and then add 2. 16 take away 8 is 8, add 2 is 10, so that's going to be 10. There you go, you can obviously keep all your working out. I'm going to get rid of that and just keep working on the next ones. So 2, we've got 2 squared, which is 4, take away 2 times 2, which is also 4, and then add 2. 4 take away 4 is 0, add 2 gives us 2. So when we sub in 2, we get the answer 2. On to the 1. 1 squared is 1, take away 2 times 1, which is 2, and then add 2. 1 take away 2 is negative 1, add 2 is positive 1. And then we can start to see a pattern. So you see we've got 1 in the middle, then we've got 2 on either side, we've got 10s here, so the chances are this is going to be a 5. And obviously we are going to have a 5 there, but it is worth subbing that negative 1 in. And again, this is another reason why I like to do the positive numbers first. But negative 1 squared is 1. Take away 2 times negative 1. Well, that's take away. 2 times negative 1 is negative 2. So it's take away negative 2 and then add 2. So that becomes a plus. So it's 1 plus 2 plus 2, which is 5. So it does give us the 5 that we're looking for, but obviously it was much easier there just to spot the pattern. From here, we just need to actually draw it in. So it says draw the graph of y equals x squared minus 2x plus 2 for values from negative 2 to 4, which is what we've done. So negative 2, we have a value of 10, so that's going to be up here. Then it's 5, 2, 1. So I'll go 5, 2, and 1. And there we go. And then it goes 2, 5, 10 again. So just each little jump across, 2, and 5 is here. And then 10 is on the 4 just there. So that's what your quadratic should look like. You just need to join that up using a nice smooth curve. So not using a ruler, a nice smooth curve, joining them all up. I'm going to flip it around the other way. And there we go, a nice smooth quadratic curve. And there it is drawn. Okay, so we've got another question about this. It says use your graph to find estimates of the solutions to the equation. And straight away, the first thing that I said, surely it's not going to be asking me estimates to the solutions, because we know that solutions are normally where it crosses the x-axis, and this graph doesn't cross the x-axis. So let's just have a look at this. It says find the solutions of the equation where x squared minus 2x plus 2 equals 4. So it's not asking us where it equals 0, it's asking us where it equals 4. So normally when y is 0, that's along here. But instead of y being equal to 0, then wanting to know when y is equal to 4. Well, here's 4 on the y-axis, and when y is equal to 4, that is going to be this line going through the graph like that. And if we want to find the solutions where it's equal to 4, all we need to do now is draw some nice straight lines going down to the axes from our graph, and we're going to estimate those numbers there. So we want to do this very carefully. So that is negative 0.5. So each little square here, I'm just looking at this part right now. So that is minus 0.5. So that's minus 0.6, minus 0.7. So negative 0.7 from our first one. And if we go across to our other one, that there is 2.5. So 2.6, 2.7, that's 2.8. My line's gone just in the middle. I probably wouldn't need to say that accurate, but I'll say 2.75. But again, yours might be ever so slightly different. So you might have 2.7, 2.6. It just depends on how you've drawn your curve and how steep you've drawn that part of your curve. So there we go. There would be my two estimates. I would say negative 0.7 and 2.75. There we go. And there would be the estimates to that equation when it's equal to 0 instead of 0. Sorry, when it's equal to 4 instead of 0. All right, on to our next one. Okay, so we have writing this as a fraction in its simplest form, and you must show your working. So these are some of the nasty ones. Now straight away, something that I've spotted is that this factorises. So before I even move on, I'm just going to factorise that, because that's probably going to be worth a mark. So double brackets, two numbers at times to make 6, could be 1 and 6 or 2 and 3, and they're going to add to make 5. Now they're all positive there, so that's plus 2 and x plus 3. Now that's annoying. It would have been nice if that was an x minus 2 in there, because then that fraction would have simplified. But here we go. We're going to do the brackets first, so we're going to come back to this 4 take away what's in there in a moment, as we've got this large bracket round it. Otherwise we'd have had to have gone left to right or followed our order of operations, but I'm going to do this bracket first. So I have x plus 3, which if I write as a fraction is x plus 3 over 1. And we're going to divide that by what we've got there. Now we know when we're dividing with fractions, we multiply by the reciprocal. So I'm going to multiply that by x minus 2 over our new double bracket that we've got, x plus 2 and x plus 3. There we go. And if we multiply those, everything on the top is going to times together. So these two, we're just going to put brackets around those and write them with their brackets, and then it's 1 times on the denominator. So this isn't too bad. This is actually simplifying really nice. So on the top of that fraction, we'd have x plus 3 in brackets, x minus 2. And on the bottom of the fraction, we have x plus 2 and x plus 3. Now we're in a position actually where this is really nice because those are going to cancel out those x plus 3's, and all we're left with is x minus 2 over x plus 2. So that's that bit in the brackets. Now we need to go back and take that away from 4. So if I write up what we've got now, we've got 4 take away x minus 2 over x plus 2. And again, I'm going to take the same approach. I'm going to write this as 4 over 1. We know when we're adding and subtracting with fractions, we need a common denominator. So if I make the common denominator x plus 2, that just means I need to multiply the left here, top and bottom, by x plus 2. So if I write that in, times x plus 2, that means my numerator, 4 lots of x plus 2, would be 4x plus 8. And on the bottom, 1 times x plus 2 just leaves us x plus 2. So there is our first fraction. We still need to take away x minus 2 over x plus 2. Now we're almost done. I've just got to be really careful. We know when we're subtracting fractions, our denominator is still going to be x plus 2. That's not a problem at all. But we are actually going to have to subtract these numerators. I need to be very careful because I am going to do the 4x, take away 1x. Probably won't have any difficulties there. That's 3x. But this next step I need to be a little bit careful with because I have plus 8. I'm going to take away negative 2. And if I just write that down to the side, that's 8 take away negative 2. And I don't want to miss that that is actually adding. So that's actually going to become positive 10. So I have 3x plus 10 over x plus 2. And there we go, that is now written as a single fraction, and that is in its simplest form. I just want to check do either of those factorise, just to see if I can divide by a common factor, but that has come out in its simplest form. So the reason it says to write it in its simplest form though, is because at this point here, when I created a common denominator, there were lots of other common denominators that I could have made, but I just made the one that was easiest, but of course I could have maybe made something slightly different, okay, if I overcomplicated it a little bit, in which case I'd need to simplify. But there we go, my final answer, 3x plus 10 all over x plus 2. And there we go, there's my final answer. And there's some algebraic fractions. Okay, so p is inversely proportional to the square root of m. Now if I write that out straight away, that's p is equal to k over root m, inverse proportion. It then says p is 10 when m is a quarter. Work out the value of m when p is 2. Well, to start with, I'll focus on this little bit of information that's given to us where it says that p is 10 when m is a quarter. So if I put those in, we know that p is 10, and that's equal to k divided by the square root of 1/4. Now when you are square rooting a fraction, you just square root the top and the bottom. So the square root of a quarter is 1/2. So that's 10 equals k over, and then the square root of 1 is 1, the square root of 4 is 2. So it's k divided by 1/2. It's a bit of a strange concept, that. Divided by 1/2. We don't really like fractions within fractions. But anyway, to rearrange this, I just need to multiply both sides by that denominator. So I can multiply both sides by 1/2, and 10 multiplied by 1/2 is just going to be 5. So we get 5 equals k, or k equals 5. I then want to put that back into my original formula, so p equals k over root m. Instead of writing p equals k over root m, I write p is equal to 5 over root m. And there we go. So when I want to work out the value of m when p equals 2. So if I put p equals 2, I've got 2 is equal to 5 over the square root of m. I probably just want to rearrange that now because I want it to say m equals or equals m. So if I multiply both sides again by this denominator, that's just going to move it to the other side. That would give me 2 root m is equal to 5. And then I can divide both sides by 2 to get rid of the 2. And that would give me root m is equal to 5 over 2. You could write that as 2.5, but I can already see the next step now is obviously to undo this square root just here. And to undo a square root, I want to square both sides. So if I square both sides, I would get m is equal to 5 over 2 squared. And if we square both of those, we get 25 over 4. Now it would have been fine to leave it as a decimal, but you'd have had to have done 2.5 squared, which is not a problem. You just do 25 times 25, hop the decimals back in, and that's absolutely fine. But for this one here, I can just leave my answer as a fraction. It doesn't say it needs it as a decimal, so 25 over 4 would be absolutely fine. You could even write it as a mixed number if you wanted. What would that be, 6 1/4? Absolutely fine for you to write it in any of those methods, or 6.25. So there we go, there is some inverse proportion, non-calculator, where we had fractions involved. So here we go, prove algebraically the recurring decimal 0.25 recurring has the value 23 over 90. So for this one here, we'll say, okay, well, x is equal to 0.25 recurring. There is one recurring decimal, so we just need to times by 10. So x is equal to 2.55 and recurring on the 5, just making them balance. Take them away from one another. I know some people do this slightly differently. You might do the 10x and the 1000x or 100x, or there's lots of different ways that some people do it, but I just like to do it the quickest, easiest way for me. Take those away and we get 9x is equal to 2.5, take away 0.2 is 2.3. We don't want a decimal in here because we're going to create a fraction, so times them both by 10, 90x equals 23, and then divide by 90, you get x is equal to 23 over 90. And there we go, we've proved it. Now the one thing you might want to do here, obviously we are proving algebraically, so we might want to write here the fact that we times both sides by 10, that was all part of the proof, and then we're also dividing by 90 here, so we just want to show those steps, as obviously that is part of the proof, and if you asked to write this in its simplest form or as a slightly different way, this actually doesn't simplify, but if it did ask you to write it as a simpler fraction, you'd also have to show the steps on how you simplified it too. So there we go, there is some recurring decimals. This says the nth term of a sequence is given by an squared plus bn, where a and b are integers. The second term of the sequence is -2. The fourth term of the sequence is 12. Find the sixth term of the sequence. Okay, so interesting question. So when you are finding the second term in a sequence, that means n is equal to 2. When you are finding the fourth term of a sequence, that means that n is equal to 4. And I'm sure if we sub those in, that's going to give us some form of equation, because it has to equal -2 in the first one, and it has to equal 12 in the second one. So if we put that in, and remember this is n squared, and this has an n, so n squared, if we square the value of n, so 2 squared is 4, and rather than writing a4, I'll write 4a. So 4a plus, and then n is 2 again. So again, rather than writing b2, I'll write 2b. So 4a plus 2b equals -2. For the next one, 4 squared is 16, so 16a. Plus, again, I put the number first, 4b, and that is equal to 12. And there we go, we have two equations, and we can solve these simultaneously. If we solve them simultaneously, we know what a and b will be, and then we can use that with the sixth term using n equals 6, and we can solve this whole problem. So if we solve these simultaneously, I'll make the b coefficients the same, so I'll times this one by 2. So that equation would be 8a plus 4b is equal to -4. Now I don't need this top equation, I just need to subtract them as they've got the same signs. So 16a take away 8a is 8a, the 4b's disappear, and then 12 take away -4, so that's 12 add 4, so that'd be 16. So a is equal to 2, 16 divided by 8 is 2, I can use that, substituting it back into one of these equations to find the value of b. Now that second equation here, we don't have any negatives involved, so I may as well sub it back in there. If a is 2, then 16 lots of 2 would be 32. So 32 plus 4b equals 12. As it turns out, I'm going to get negatives anyway. Take away 32 from both sides. We get 4b is equal to negative 20, and then divide by 4. So b is equal to negative 5. So I've got my value of a, and I've got my value of b, and I can now pretty much solve this problem. But it's not the nicest question, to be fair. So putting that back in, an squared plus bn. So that's 4n squared, sorry, 2n squared, because a is 2. So 2n squared plus bn, well that's plus minus 5n. And that would be a bit of a strange way of writing that. We normally wouldn't put this plus sign. So we'd just put 2n squared minus 5n. That's fine, we can just move that across. There we go, 2n squared minus 5n. So that there is the nth term of this sequence. So to find the sixth term for our final step, we'd want to just substitute 6 into that equation. So we'd have 2 lots of 6 squared, take away 5 lots of 6. Now to be fair, I'll probably put that squared on the outside. Doesn't actually make any difference to our calculation. But there we go. That's what I need to work out. So that's 2 times 36. Take away 5 times 6 is 30. 2 times 36 is 72. So 72 take away 30. 72 take away 30 is 42. So there we go. There's our final answer, 42, and that would be the sixth term in the sequence. And there it is. Not the easiest of questions, to be fair. We had to obviously link the fact that the second and fourth term were just the values of n. Putting that in to make two equations, we actually had simultaneous equations then, and using those simultaneous equations to then go ahead and plug those back into the nth term. So then once we had the nth term, we could just use it again, which we'd already used earlier on anyway, substituting the n values in. But there we go, 42 is our final answer. Here are the first 5 terms of a different quadratic sequence. Find an expression in terms of n for the nth term of the sequence. So first things first, we need to find the first and second difference. So 12, 20, the first difference, 4, 4, I don't know why I put 4, there we go, 2, 4, 6, 8. The second difference then is 2. And if we have a second difference of 2, I know some people use the formula for this. I tend to just halve the second difference. So I know that it's n squared at the start. You can use whatever method you prefer. This is just the method that I prefer. And then we want to write out the square numbers. So n squared, if I write that out, is 1, 4, 9, 16, 25, the square numbers. How do we get back to our sequence from the square numbers? So 1 to 0 is taking away 1, 4 to 2 is taking away 2. So unfortunately, it's not just going to be a simple n squared add or minus something. Okay, I'm going to put the n squared here. So to get from 1 to 0, that's minusing 1, then minusing 2, then minusing 3, 16 to 12 is minusing 4, and so on. So we know it's going to start with n squared, we just need to find the nth term of this sequence. And if we find the difference between these, -1 to -2 is subtracting 1. -2 to -3 is also taking away 1. So that would be minus 1n. Of course you wouldn't have to write that as minus 1n, you could just put minus n. So we know that that part is minus 1n. Now it's a bit of a strange one, but the -1 times table starts with -1. I know some people do like a little trick where you go backwards, and that gives you the term 0. Or in other words, it's -n plus 0, because this is the -1 times table. Not that we ever really use the -1 times table, but if we did, that would just be -1 at the start. So this is the only part that we have left. We've just got minus n. So our quadratic nth term is the n squared and then minus n. Okay, on to our next question. Okay, so it says Maria throws a fair coin n times. Find an expression in terms of n for the probability that Maria gets at least one head and at least one tail. Now, this is a bit of a nasty one, but if we think about a probability tree and how we draw this if we were working out probabilities, the probability of getting a head and a tail is 1/2. If we then did another throw, and obviously it says n times, so we don't know how many times we're going to do this, but if we just imagine we did it twice and what that would look like, it would look like this: 1/2 and a half, and a half, and a half. Now, any of these two roots, a head then a tail, or a head then a tail, would give us a head and a tail. But even if we continue doing this, and we don't know how many times, but however many times we did it, the important part is there are two roots on any given size of this tree that will never give us one of each. And that is if we went all the way along the outside and continued to get a head every time, or continued to get a tail every time. Now, those roots there, if we were to work out the probability of that happening, you would do a half multiplied by a half multiplied by a half, however many times that you did it. Or in other words, 1/2 to the power of however many times. The same over here. This would be 1/2 to the power of however many times. So to work out what's left in the middle, thinking about probabilities, they all have to add up to 1. So we would just do 1, take away this probability, a half to the power of n, take away this probability, a half to the power of n. So if we write that as what it's asking for, an expression, we would say 1, the total that it has to add up to, take away a half to the power of n, take away another half to the power of n. And that would be absolutely fine. That would be an expression, that would be correct. We don't have to simplify that. That would just be exactly how we'd work it out. And that would be the probability that Maria gets at least one head and at least one tail. But that's a really nasty little question there. It's not particularly nice at all, but hopefully that sort of gives you an idea of how you might approach it and think about it just on a smaller scale rather than in terms of n for however big that tree could be, because obviously we don't know, there could be 50 times or more. But if we just think about if it happened twice, how we do that, just help to visualise that. So there we go. Right, question 19, we've got a histogram. So this histogram shows some information about the age of 134 members at a club. Let's see what we've got then. It says 20% of the members who are over 50 years of age are female. Work out an estimate for the number of female members who are over 50 years of age. So 20% of the members who are over 50 years of age are female, and it wants us to work out an estimate for the number of those. So we need to actually have a look at our histogram and actually think about the numbers within each of these bars. So we know the frequency within a histogram is just the area of each rectangle. So I just need to go about working out the area of each rectangle. I need to read the scale very carefully. So let's have a look. Let's just get the height of these bars first. That's going to save me some time. So that's 1.1. This one up here, let's just draw another lining because I'm going to erase that. That's 2.6, 2.7, 2.8. So that's 2.8 for that one. Let's just get rid of some of that mess. This one here, let's have a look. That is 2.1, 2.2, 2.3. There we go. Let's have a look over here. Going along really carefully. That's 1.4. 1.4. Again, you could do this with a ruler and pencil. That one there, 0.6, 0.7. So that one's 0.7. Again, I'll just get rid of that, otherwise it's going to look like a right mess. So if we work out the area of each bar, that first bar has a width going across from 0 to 10. So 10 times 1.1, that would be 11. Again, I'd probably want to write these down to the side. 10 times 1.1 is 11. So there's 11 people in that first bar. The next one has a width of 10 as well, and that has a height of 2.8. So 10 times 2.8 is 28. There we go. So 28 people in that bar. The next one has a width of 20. So that would be 20 times 2.3. What's that? That's double 23, so 46. So there's 46 people in there. The next one has a height of 1.4, again another width of 20. So 20 times 1.4, that's double 14, so that's 28. 28 in that bar. And the final one, 0.7, and that has a width of 2030. So that's 30 times 0.7. There we go, so times that by 10 is 7, times it by 3 is 21. So 21 people in that bar. So that's the frequency of each bar. Let's just have a look now what it's asking. So in terms of people that are over the age of 50. So in terms of the age, where does 50 lie? Well, 50 lies just here. So if we were to make an estimate, well, if we were to split that bar going up, then everyone on the right of that bar is over 50. So how does that help us? Well, if we get rid of this 28, so if that whole bar there is 28, and bearing in mind we're just making an estimate, we would estimate that there's 14 on the left and 14 on the right. So that means on the right of the bar there, so above 50 years of age, we've got 14 plus the 21. So we would say, and let's just highlight that, and hopefully we're happy with that concept. We've got 14 there, 21, so there are 35 people over 50 years of age. So 35 people, or let's just say 14 plus 21, 35 people over 50. It says 20% of the members at the club who are over 50 are female. So we need to work out 20% of 35. Well, 10% would be 3.5. Double that for 20%. So 20% would be 7. So hopefully that has answered the question. Work out an estimate for the number of female members who are over 50 years of age. We have 20% of them are female. There are 35 people over 50, and 20% of 35 is 7. So that'd be our final answer there, 7 people. And that is the female members who are over 50 years of age. Yep, I'm happy with that. But always got to be careful with these because the scales are always just really fiddly to actually read. But there we go, I'm happy with all those numbers, happy with 7. It's come out as a nice whole number. So chances are that's going to be right. It is right, but yeah, chances are if you get a whole number, it's going to be right. Okay, so looking at some similar shapes. It says LMN is a right-angled triangle. The area of PNQ is 8. That is the triangle PNQ just there. And the area of triangle LPQ is this one here, and that one has an area of 16. Now those two triangles are not similar triangles because they share that same height there, but they've got different length bases. But the triangle NPQ and the larger triangle here, they are similar triangles. They both share that parallel line. You can see obviously highlighted by this parallel line symbol here, and they're both fitting within one another, and they both have this same angle here. They've got a right angle as that's a parallel line. So those two are linked, but these two triangles here, PNQ and LPQ, they are not the same length, but they have double each other's area. Now as they share this line here, that means if this one, for example, had a length of 1 from P to N, then in order for that triangle just below it to have double the area, this length here would have to be double the size. Let's imagine it's 2. So in order for that to work, and that to be double, that means to get from NPQ, the side length N to P, to get to the full length, that would be a length of 3. And if we get rid of this length of 2, that means that those two similar triangles, PNQ, and the larger triangle, NLM, this one here, they must have a linear scale factor of 3. To get from 1 to 3, you multiply by 3. So the linear scale factor, or we could write the LSF, is equal to 3. That means the area scale factor between them, as we're looking at areas, would be equal to 3 squared, which is obviously equal to 9. So to get from the smaller area to the area of the full triangle, we'd have to multiply it by 9. So if that smaller triangle has an area of 8, to get the area of the whole thing, we would do 8 times 9. And 8 times 9 will give us an area of 72 centimetres squared. But that is for the triangle NLM. Now this question wants us to work out the area of LQM. And LQM is just this part here. But if we think about what we do to actually get just that part, well, we'd get the area of the whole triangle. We would take away this area here, and we know that that area there is 16. And then we would also take away the area of the smaller triangle here, NPQ. So we know the full area is 72, and we just need to get rid of those smaller areas. This one here is 8, this one here is 16. The total of those, 8 plus 16, is equal to 24. So we just need to get that away from the full triangle. The full triangle is 72. So 72 take away 24 would leave us with 48 centimetres squared. And that would be the area of that shaded region there, LQM. So there we go, our final answer would be 48. That's quite a nasty question. The actual difficult part there was spotting that the linear scale factor from n to p and n to l was a scale factor of 3. Just spotting the fact that those, what I've highlighted as yellow and green, the yellow and green triangles, their areas would double one another, so therefore that length would have to be in that ratio 1 to 2, or twice as big, and that meant the full length is 1 to 3. But there we go, there are some similar shapes. On to question 21. A nice one here for part A. Rationalise the denominator of 22 over root 11. Give your answer in its simplest form. So when you're rationalising, multiply the top and bottom by root 11. And that on the top will give us 22 root 11. And on the bottom, we get the square root of 121, which is the whole number 11. So that's quite nice. For that particular one, the top and the bottom both divide by 11. So I can write that there. Divide the top and bottom by 11. And if we do that, 22 divided by 11 is 2. So we get 2 root 11 over 1. You don't need to write that over 1. So you can just write 2 root 11 as your final answer. So there we go, quite a nice rationalising question there for part A. Part B, we've got a slightly trickier one. Show that root 3 over 2 root 3 minus 1 can be written in the form a plus root 3 over b, where a and b are integers. So when we're doing that, you want to multiply the top and bottom by the 2 root 3, but we are going to change that symbol to a plus 1. So we're going to multiply it by 2 root 3 plus 1, and the bottom by 2 root 3 plus 1 as well. Now that means we're going to have a double bracket on the bottom and a single bracket on the top. So root 3 times 2 root 3, well, that'd be 2 times 3, which is 6. Root 3 times 1 is just root 3, so 6 plus root 3. And that's already matching what it wanted on the top, a plus root 3. On the bottom, we have a difference of 2 squares, so I don't have to multiply all 4. I can do 2 root 3 times 2 root 3, which is 4 times 3, which is 12. And then I can just do the negative 1 times the positive 1, which is minus 1. And if we simplify what we've got on the bottom there, we have 6 plus root 3 on the top still. 12 minus 1 is 11. So 6 plus root 3 all over 11. And there we go. There's rationalising some harder surds. 6 plus root 3 over 11. Okay, so our next question, we have got some problem solving with indices. We have indices here where we have different base numbers. They do share the same powers, and we'll look at that in a second. They've got some negative fractional powers and some algebraic powers. Now, whenever you see questions like this, first of all, we want to look at these base numbers. So 9, 27, and 3. And we just want to think about if they share a power of something. So they do. 3 is 3 to the power of 1. 9 is 3 to the power of 2. And 27 is 3 to the power of 3. So instead of writing them as 9 and 27, we can write them as a 3 to the power. So 9 we can write as 3 squared. Well, that is all still to the power of negative a half. And that's equal to 27 is 3 cubed, although that is all to the power of a quarter. And that's being divided by 3 to the power of x plus 1. Now we've got everything as a base number of 3, we can approach this by simplifying the powers. So we know that when we have powers in brackets, we multiply the powers, so we'll multiply those, and we'll multiply these, and we'll rewrite it. So 2 times negative a half, or 2 times a half is 1, so that'd be minus 1. So we have 3 to the power of minus 1 is equal to, that 3 times a quarter is 3 quarters, so 3 to the power of 3 quarters, divided by 3 to the power of x plus 1. Now there's a few different ways that you could approach this, but we want to find that value of x. So what we could do is we could times both sides by the 3 to the power of x plus 1, if we want to rearrange them that way. Or we could think about what you do in terms of dividing. You take the power of 3 quarters and subtract the power of x plus 1. There's lots of different ways that we could approach this. But I'm going to multiply both sides by this 3 to the power of x plus 1. And just see what happens if I do that. If I do that, we have 3 to the power of negative 1 multiplied by 3 to the power of x plus 1. And that's equal to 3 to the power of 3 quarters. Now that's quite nice because we know when we're timesing, we add the powers, which would be a little bit easier than the previous powers we had, which was 3 quarters take away x plus 1. That's not very nice. But negative 1 add x plus 1, that's really nice for us to do. Negative 1 add 1 is just 0, so that just simplifies to 3 to the power of x. Negative 1 add 1 is 0. So all that becomes 3 to the power of x. So 3 to the power of x is equal to 3 to the power of 3 quarters. That's nice and easy for us to work out now, because if 3 to the power of x equals 3 to the power of 3 quarters, then x must be equal to 3 quarters. And there we go, that would be our final answer. X is equal to 3 quarters. So not overly bad. Okay, there were different ways that you could approach it when we got to the division part, where I multiplied by 3 to the power of x plus 1, but I think the way that I did it there probably made it the most simple method possible for answering that. So there we go, that was some indices problems, and now we have what looks like a Venn diagram. So reading through this question, Andy asks 50 people which drinks they like from tea, coffee and milk. And then it gives us some information. Now we've got 3 things like this. We're being asked to work out a probability. To be fair, it could be that you have to draw some form of two-way table. It's unlikely this far into the paper, but this is going to be a Venn diagram, a 3-way Venn diagram. And when we're doing this, we obviously need a bit of space, but I'm going to try and squeeze it all in over here, see if I can make it fit. So I'm going to do 3 circles for my Venn diagram and make sure I've got the box around the outside for any that don't like any drinks. So here I'm going to label it up from left to right, the ones we were given. So tea, coffee, milk. I'm just going to go through line by line, ticking everything off. So all 50 people like at least one drink. Okay, well there we go. So we've got a 0 on the outside. You don't necessarily need to write that, but it does remind me that none of them are going to go on the outside. 19 people like all 3. So 19 right in the centre there that like all 3. 16 like tea and coffee, but do not like milk. So tea and coffee, but don't like milk. 16 just there in that tea and coffee overlap, but not including the people that like milk. Tick that off. 21 people like coffee and milk, but it doesn't have this but do not like. So 21 people like coffee and milk, but we've already got 19 in the middle there that like coffee and milk as well. So this is where I don't want to forget that there's 19 included in that 21 people that like coffee and milk, so that's just an additional 2 people. Tick that off. The same for the line below. 24 people like tea and milk. We've already got 19 people that like tea and milk, so to get to 24 we need an additional 5. Tick that off. 40 people like coffee, and only 1 person likes milk, 1 person likes only milk. I'm going to put that 1 in first. Tick that off. The 40 people that like coffee, I have to look at the entire coffee circle. And if I highlight what we've got 19 people that like them all, we've got 16 people that like coffee and tea, we've got 2 people here that like coffee and milk, and at the moment that adds up to 16, 19 and 2, 17, 37. So at the moment we have 37 people that like coffee. In total we want 40, so that'd just be an extra 3 people in there. So there we go, that's my working out to get the coffee. We are missing the section for people that only like tea though. So to find the people that only like tea, we need to add all of these together, take it away from 50, because we know it's out of 50 people. We know 40 people like coffee. That was a good bit of information, because we only need to add to that the 5 here, which would take it up to 45, and the 1 here. So that's 46 in total. So 50, take away 46, it's 4 people that only like tea. Okay, so there we go. So they're the people that only like tea, just the 4 of those. We can get rid of all of that. We've done our Venn diagram. Let's see if we can answer the question. So work out the probability this person likes tea out of the 50 people that we are choosing from. So if we're choosing out of 50 people, we know the probability is going to be out of 50. We just need to put on the top how many of them like tea. So if I add them all together, we've got 5 plus 19, which is 24, plus the 16, which is 40, plus these 4, that is 44. So 44 people like tea out of the 50, and there we go, lots of marks for that one, so 44 over 50. We've got a part B for this one. So given that the person selected at random likes tea, find the probability that this person also likes exactly one of the drink. Now we already know that 44 people like tea, so we know that this is going to be out of 44, because it says given that we pick one of the people that likes tea. So what's the probability they like exactly one of the drink? Well, let's have a look. So out of the people that like tea, we don't want these 19 because they like 2 of the drinks. So the people that like tea, that like exactly one of the drink, we've got the 16 here, and we've got the 5 here that like milk as well. So you've got 16 add 5, and that'd be 21. So I'll write this down here. So 16 add 5 is 21. So that'd be 21 out of the 44 people that like tea, like exactly one of the drink. And there we go, extra marks there for not much more difficulty in that question. Some good extra marks. Okay, on to this one. So question 24. We have got the region R in the diagram is the region between 2 circles with the same centre. So we can see that there, we've got this shaded region. The outer circle has a radius 2n plus 6, the inner circle n minus 1, and all measurements are in centimetres. The area of R is greater than the area of a circle with the radius n plus 13. N is an integer, find the least possible value of n, and you must show your working. So to work out the area of a shaded region, we'd get the area of the large shape, which is the area of the big circle, take away the area of the unshaded region, which is the smaller circle. So I need to get the area of both of those. So if I get the area of the large circle, that would be 2n plus 6 is the radius squared, and it's pi r squared. So it would be pi multiplied by 2n plus 6 squared, and we want to take away from that pi r squared for the smaller circle, so pi times n minus 1 squared. That there is going to give me the area of the shaded region. So if we go about actually working that out and sort of simplifying that, we have got, for the 2n plus 6, we've got double brackets there. So you've got 2n plus 6 and another 2n plus 6, and for this one here you've got n minus 1 and another n minus 1 to work out, squaring those brackets. If we do that, 2n plus 6 times 2n plus 6, well, you get 4n squared. 2n times 6 is 12n, we've got 2 of those, so plus 24n. 6 times 6 is 36, and there's that one. We've then got the n minus 1, so n times n is n squared. N times minus 1 is minus n, you've got 2 of those, so minus 2n. And negative 1 times negative 1 is plus 1. And we're taking all those away. Okay, so if we do that, we're going to need to be careful, because we are going to be doing this. Pi lots of that. Take away. I can just about fit my pi symbol in. Pi lots of that. And we can go about simplifying that in just a moment, but let's just have a look at the n parts to start with. before we do that, instead of multiplying by pi, there is actually a way that we can make this a little bit simpler, because it says the area of R is greater than this circle here with a radius n plus 13. And if we go about working that out, it's the same same process really. Pi times n plus 13 squared, which is what we've just done for the ones above. Again, that's just a double bracket, so n plus 13, n plus 13. And if we expand that, you get n squared plus 2 lots of 13n, so 26n, plus 169. And again, it's pi lots of that, as we're looking at area of a circle. So where it says greater than, the area of R is greater than that, that's going to set up an inequality. So if we take all of this, we know that that is greater than all of this. And if we write that out, we would have pi lots of 4n squared plus 24n plus 36 take away pi lots of n squared minus 2n plus 1, and that is greater than pi lots of n squared plus 26n plus 169. Now, because we now have a quadratic equation to solve, or an inequality, we can actually divide both sides of this by pi. I can divide this side by pi, and I can divide this side by pi. And essentially, that's just going to cancel all these pi's and just make it a little bit easier to approach. So now I'll have 4n squared plus 24n plus 36 take away n squared minus 2n plus 1, and that is now greater than, I don't need to put this bit in a bracket anymore, n squared plus 26n plus 169. Now I think it's important to do that because this next part is something you need to be careful with anyway, because we're doing a take away and there's 3 things that we're taking away. So not too bad, but we've got 4n squared take away n squared, so we get 3n squared. We've got plus 24n take away negative 2n. When you take away a negative, we're going to be adding the 2n, so plus 26n. And then we've also got this plus 36 take away the plus 1, so that'd be plus 35. And that is now greater than n squared plus 26n plus 169. Now what we want to do is actually rearrange this. So we want to get it to a point where we either have n's on the left, numbers on the right, or we have some form of quadratic that we want to factorise and solve. So I think the next thing to do is to rearrange it. So we'll minus n squared from both sides, and that would give us 2n squared. We also want to minus 26n from both sides, minus 26n, and we only have 26n on both sides, so that's going to disappear completely. So if we just write out what we've got now that they've disappeared, so we've got 26n squared, sorry, 2n squared plus 35 is greater than 169. So at this point, rather than making it 0 on the right hand side, what we can actually do is get rid of or subtract 35 from both sides. If I get rid of 35 from both sides, I get 2n squared is greater than, what's that going to be? Is it 134? Yeah, 134. I can now divide both sides by 2. So 1n squared is greater than 67. And now we're at a position where actually we can give an answer. So we know that a number squared has to be bigger than 67. Well, we know that 8 squared is 64, and that's not big enough. So 9 squared would give us 81. And we know that it says n is an integer just up here, so 8 squared isn't big enough. And it did say find the least possible value of n. Well, 8, not big enough, we can't have that, but 9 does give us an answer bigger than 67. So our answer here would have to be 9. There we go. So we could say n equals 9. We could just write it like that. So a lot of working out there, mainly based on area of a circle. You had a quadratic inequality there, although not the nastiest because you didn't have to make it 0 on the right hand side and factorise it and solve it that way. But obviously that position there, particularly when you're good at quadratic inequalities, you can sometimes forget that actually you can take this slightly easier approach here, just putting the numbers on the right and the values on the left. But that only really happened because at this point here, we got rid of that 26m from both sides. So it made it quite a nice one for us to solve. Right, so there we go. And that is the end of the paper. That was the last question. So there we go. Hopefully you found that useful and helpful. Again, don't forget, these are not all of the topics or necessarily even the question styles that might come up, but there's a really good selection of questions there. And across this paper and the paper 2 and 3, there's going to be pretty much the large majority of those questions. And again, I'll be ticking off the checklist just to show you exactly all the topics that appear. But there we go. There was a really good selection. Hopefully you enjoyed that. So there we go. Don't forget to stay subscribed for these future videos, and don't forget to check in the description so that you can check paper 1, 2 and 3, all of the lessons that come along with it. And obviously you can go into there, you can download the booklet, and you can download that revision checklist. So there we go, that's the end of the video. Hopefully you found that useful and helpful. If you did, don't forget to like, don't forget to comment, don't forget to subscribe, and I'll see you for the next one.